Welcome, dear students. We are meeting again today. I want to share with you the fifth lecture. It is on differential equation solvable for P. Just to review or recap what you did previously, in first lecture we have how we solve the differential equation solvable for P. Where does P exist? What does P stand for? Then we have the equation is solvable for Y, then equation is solvable for X, then equation is where this X is absent. How we go ahead? Now we have the case fourth I want to share with you. This is case fourth. This is case fourth. It is when differential equation is free from Y, that is Y absent. Differential equation does not involve Y, means it will now involve only what? X and P. So there exists the relation. In this case we have a relation between what? Between X and P. We have a relation between X and P. We have a relation between X and P. Now this relation can be of two types. Number one, subcase in this fourth case, if P is some function of X, because there is the relation between P and X and P. If suppose P is some function of X, how will you proceed? You will use the value of P as dy by dx is equal to some function of X, which means that your dy is some function of X into dx. So variables are separated. You can easily differentiate this by applying integral and adding the constant of integration. In this case it is very simple. If P is a function of X, Y is missing. But if X is a function of P, subcase of this case, now if you have next case, if X is some function of P, how we do? That means we will differentiate dx by dy. It is g dash p dp by dy. Then we proceed as case number second. You will switch to previous lectures where we did that when Y is a function of X, Y is a function of X and P, how we do? When X is a function of Y and P, how we do? The case where X is a function of Y and P, this is the same. You will do it, differentiate with respect to X and use this as 1 by P and proceed. The case is done. Now we have almost discussed all the cases in this case. Now only one thing remains, that is a Clairaut's form. Clairaut's will be the last here. Before that, I will share with you some problems. These are mixed problems we will share so that you are in a position to do the problems from your books which you have at your disposal in BTech engineering books, or you have the books from this BSc mathematics and undergraduate level, so on. Let me have some problems. These are the mixed problems that I want to share with you. Suppose I have a question here. Question is, these are mixed problems. Mixed problems I want to share with you. Solve the differential equation. Solve, it is P is equal to tan of X minus P by 1 plus P square. This is the question. First you look at this question. When you just look this, you find that here y is missing. Y is missing. Number 2, this can be written as function of x. Y missing. How you proceed? You can write this equation as tan inverse p is equal to x minus p by 1 plus p square, which gives you x is tan inverse p plus p by 1 plus p square. This is equation number 1. X expressed wholly as a function of p when y was missing. What we do? We differentiate this with respect to y. Let us differentiate with respect to y. How we proceed? Derivative of x with respect to y will be dx by dy. Tan inverse differential, it is 1 by 1 plus p square, but p is a function of x and y, so p will be here d p by dy. Then plus, here I can go by division rule, denominator square, 1 plus p square whole square, 1 plus p square whole square. Then here p as it is, derivative of this is 2p dp by dx minus denominator as it is 1 plus p square, derivative of numerator with respect to p is dp by dy minus, then you write p as it is, derivative of 1 plus p square is 2p dp by dy. This is the division rule I have used here. Now let me simplify this. Let us simplify this. How we go? This will be your 1 by p. This is 1 by 1 plus p square. Taking this dp by dy throughout common, you can take throughout common. Here you have dp by dy. Here also you have dp by dy. It is plus 1 plus p square by, it is 1 plus p square whole square here. Then it is minus 2 p square by 1 plus p square whole square. dp by dy is out. How you proceed? It is 1 by p is equal to, you can write it 1 by 1 plus p square, then plus, it is 1 by 1 plus p square, this is minus 2 p square by 1 plus p square whole square. It is dp by dy. Well, you simplify this. You can take here 1 plus p square whole square will be LCM throughout. It is here 1 plus p square plus 1 plus p square minus 2 p square. It is dp by dy. This will be here only 1 by p is equal to 2 by 1 plus p square whole square dp by dy. I can separate the variables here. I can write it, it is dy is equal to 2p by 1 plus p square whole square dp. So variables are separated. Variables are separated. You can integrate now. Let us integrate. Integrate both sides. You get when you integrate on both sides, what you get? Integral of 1 dy is equal to integral of 2p by 1 plus p square whole square dp plus c. You can write this y. It is integral of, it is 1 plus p square raised power minus 2 2p dp plus c. Now what is it here? It is fx raised power n f dash x. your fundamental result. Fx is 1 plus p square, its power is minus 2, the derivative of 1 plus p square is 2p, fx raised power n f dash x. So this will be y is equal to 1 plus p square raised power minus 2 plus 1 by minus 2 plus 1 plus c. Well, you write it y, it will be y is equal to minus 1 by 1 plus p square plus c. Now it will take time here to eliminate the p. So what we do, we write this is the solution. This is solution with given equation, first equation, because there you have x is equal to function of p and here you have y is equal to function. I have already told you, when it becomes a bit difficult to eliminate p, what we write, we express x function of p and y function of p. These two equations together give the solution of the given differential equation. This was one mixed problem that I discussed with you, where y was missing here. This here x was, it was a function of x was a function of p. This is one problem that we have done here. Let me take one more example. So this question, it was your x plus p by under root of 1 plus p square is equal to a. Okay, name this first. This is your x is equal to a minus p by under root of 1 plus p square. This is now your function of what? This is the function of p. Y is missing. In this case you have y missing. X is a function of p alone. Differentiate with respect to y. Differentiate with respect to y. It is dx by dy is minus denominator square, denominator as it is. This is dp by dy minus p 1 by twice under root of 1 plus p square 2p, here also dp by dy. This gives you 1 by p is equal to minus 1 by 1 plus p square, 1 by 1 plus p square. This 2 and 2 goes. It will be on simplification 1 plus p square minus p square by under root of 1 plus p square into dp by dy. You can write it 1 by p is equal to minus 1 by p square goes, minus 1 by 1 plus p square raised to power 1 by 2 plus 1. It is 3 by 2 dp by dy. Now you can separate the variables here easily. Separate the variables. You separate the variables are separable. You can write it dy is equal to minus 1 plus p square raised to power minus 3 by 2. It is p dp. So variables separated. It is integral of 1 dy is minus integral of 1 plus p square raised power minus 3 by 2. Here I will write 2p. Here I will divide by 2. It is dp plus c. You can write y is equal to this is minus 1 by 2. This will be 1 plus p square minus 3 by 2 is minus 1 by 2, minus 3 by 2 plus 1 upon minus 1 by 2. Why it is so? Why it is so? Because it is your fx raised power n, it is f dash x. Fx, this is your n, f dash x. Okay? So you write fx raised power n plus 1 by n plus 1. Fundamental result that I am using here, you know it. So I am getting here y is equal to 1 plus p square minus 1 by 2 plus c. I can write it y minus c is equal to 1 plus p square raised power minus 1 by 2, or I can write 1 by y minus c is equal to 1 plus p square raised to power 1 by 2. I can square on both sides. I can find out here, I can eliminate p. I may eliminate here p, so I am getting here 1 plus p square will be equal to 1 by y minus c square, y minus c square. So p square will be 1 by y minus c square minus 1. Let us use it, use in given equation. I will use this in given equation, the value of p square. What is that? What was that given equation? Your given equation was x is equal to a. It was x is equal to a. It was x is equal to a plus p by x plus x minus a is equal to minus p by under root of 1 plus p square. I am using it in second equation, given equation second. Okay, if I square it on both sides, squaring, what I get, x minus a square is equal to, it is minus p square by 1 plus p square. I can use the value of p square easily here. What is value of p square? You see what is this now? This is minus value of p square I can use, or p square is your 1 by y minus c square minus 1. Here also 1 plus 1 by y minus c whole square. It is here 1 plus 1 by y minus c square. The value of p square, here it is minus 1. Now simplify. I will simplify it because it was very easily here to eliminate p. That is why I took it in this way. This is your x minus a square is equal to, on simplification, it is 1 minus y minus c square, y minus c square division by y minus c square by this is this and this goes 1 by y minus c square. Now this is cancelled. It is x minus a square is equal to 1 minus y minus c square. Therefore your solution will be now, what is your solution? You can say solution is complete solution x minus a square plus y minus c square is equal to 1. This is the solution. We have also eliminated here p. Sometimes it is very easy to eliminate p, so you have got this solution of the differential equation. Let me take one more example. Suppose we want to solve it. I will take one more question here. Suppose I want to solve a particular question. This is the question. Solve y square is equal to a square into 1 plus p square. I will solve in, say, two ways. In first case, I will take y as a function of p because x is missing here. First method I will do here, method number first, because you can sometimes go in question is, if it is a x is equal to function of p, you can write p is equal to some function of x, or x is equal to when y is missing. When y is missing, I have told you, you can write y is missing, you can write x is a function of p or p is a function of x. Now here x is missing, you can write y is a function of p or p is a function of y. That is why we write here in two ways. In two ways means, in the first way I will write y is a function of p, and in second method I will write p is a function of y. Okay, you see, first method I will do here, I will take y square is equal to a square into 1 plus p square. This is first equation. I can write here y is plus minus a under root of 1 plus p square. What we did, we have expressed this y as a function of what? This p. We differentiate with respect to x. Differentiate with respect to x. What is this? It is dy by dx is equal to plus minus a. It is 1 by twice under root of 1 plus p square. Internal derivative of 1 plus p square, you can write it 2p dp by dx. Then it is your p is equal to plus minus 2 goes 1 by a by under root of 1 plus p square. It is p dp by dx. You can easily separate the variables here. You can easily separate the variables. You can write your dx is plus minus 1 by under root of dp. So variables got separated. So you write integral, it is x is equal to plus minus integral of 1 by under root of 1 plus p square dp. You have here two methods. One is sign inverse. How? You know what is integral of dx by under root of x square plus a square. You know it is sin inverse x by a, or you can write it what? Log of x plus under root of x square plus a square by a. I will write it x is equal to log of, it is your p plus under root of p square plus 1 by a. So this is the solution. Here it is difficult to eliminate plus c here, constant of integration. So this is the solution. In this case, this is solution with given equation. What is your given equation? Your given equation was y is equal to plus minus a under root of 1 plus p square. Because here you could write x as a function of p, constant. Here y is function of p. So this and this together constitute the solution of the given differential equation. As we have already told you, when it becomes a bit difficult to eliminate p, it is better to write the solution x in terms of p and y in terms of p. These two together will constitute the solution of the differential equation. This was the first method for the same question. Now I will take second approach. This was the first approach. Let us take second approach. You can have second approach. I will name it method second. Method second for same question. I am solving the same question in two ways. When I could write y function of p, now I will write p as a function of y. You see how it is. Your question was y square is equal to a square into 1 plus p square. This was our question. In this case, I will write y square by a square is equal to 1 plus p square. This is second approach for the same question. You will adopt that approach then, which seems easy for you. This is y square is equal to y square by a square. You can write it is y square by a square minus 1 is equal to p square, or this means p is equal to plus minus under root of y square minus a square by a. This is your p. Now what is P actually? It is dy by dx is equal to under root of y square minus a square by a. So variables are separable. You can write dy by under root of y square minus a square is equal to, you can write a here, it is 1 into dx. So variable is separated. So what is our solution? It is a integral of dy by under root of y square minus a square is equal to integral of 1 dx. Yes, what is the solution of this question now? This is your a integral of dy by under root of y square minus a square is equal to x plus c. It is now this form. You know what is integral of dx by under root of x square minus a square. It has three forms. One is dx by a square minus x square, you know, that is sine inverse x by a, or minus cos inverse x by a. Second is x square plus a square, that is sine inverse x by a or log of x plus. Now it is x square minus a square. This you can write cos inverse. You can write this is cos inverse x by a, or this is log of x plus under root of x square minus a square by a. This is the formula for this. So you can write this is a log of what? Y plus under root of y square minus a square by a is equal to x plus c. You will write this is the solution. This is solution. In this case, you have not to eliminate p. This automatically is the solution, because you could write this y, this p as a function of y. Do you follow? It involved directly x and y. P gets eliminated in second. For the same question, we have attacked it in two ways: first approach and second approach, when we could write y function of p, p as a function of y. I understand you have understood this question in two ways. So there is no hard and fast rule for this, that you write only function of y or function of p. You have to see which one will be the simplest one. You will go accordingly. Suppose you have one more problem here. You have one more problem. You want to solve mixed problem is here. Solve. It is y minus 1 plus p square raised power minus 1 by 2 is equal to b. You want to solve this one. You can write this as your y is 1 plus p square raised power minus 1 by 2 plus b. You can go this way also. What is here? X is missing. Y I have written as a function of p. Another approach is if you differentiate this on both sides. Sorry, this you can go this way also. Let us do this way. I will write it y minus b is equal to 1 plus p square raised power minus 1 by 2. This will give you 1 plus p square raised power minus 1 by 2 raised power 1 by 2 is 1 by y minus b. When you square it, 1 plus p square is 1 by y minus b square. Okay, this gives you p square is 1 by y minus b whole square minus 1. You can go this way also. How you can tackle this problem now? This you can write your p square is 1 minus y minus b square by y minus b square. This gives you p is under root of 1 minus y minus b square by y minus b. Do you know, I have expressed this as a function of y. How you go now? What is it? How will you do it? You will write p as dy by dx. It is under root of 1 minus y minus b square by y minus b. You can separate the variables here. It is y minus b by under root of 1 minus y minus b square. It is dy is dx. So variables separated, you can integrate on both sides. I am discussing with you some mixed problems where you can write p function of y, y function of p, x function of p, y, and so on and so forth. Well, when you integrate it, what you get? It is integral of y minus b dy is under root of 1 minus y minus b square is equal to integral of 1 dx plus c. Yes, can you integrate it? Very easily. You can integrate in two ways. One way is substitution. Another way is this. You can go this way. It is 1 minus y minus b square raised power minus 1 by 2 into y minus b dy is equal to x plus c. What I am doing? I am trying to write this fx. This is your fx and f dash x. Now you see what is the derivative of this. If we differentiate this, if you differentiate this, it should be here minus 2 y minus b. You have y minus b, you need minus 2 here. You see how you do. You write here minus 1 by 2. It is integral of 1 minus y minus b square raised power minus 1 by 2. It is your minus 2 times y minus b dy is x plus c. Just look again. It is your fx and the derivative of this is minus 2 y minus b. I wrote it here minus 2 y minus b, but I had no minus 2 here. I have divided it. Now it takes the standard form. This is the standard form of this. This is minus 1 by 2 1 minus y minus b square raised power minus 1 by 2 plus 1 is equal to x plus c by minus 1 by 2 plus 1. It is just for your simplification so that you will recollect your formula. What formula we are using? That is why I have written here fx raised power n plus 1 by n plus 1, and automatically this will get, it is minus times here minus 1, it is minus plus 1 by 2, this is minus 1 by 2, it is minus 1 times 1 minus y minus b square raised power 1 by 2 is equal to x plus c. That means I am getting 1 minus y minus b square raised power 1 by 2 is minus times x plus c, squaring on both sides. This is 1 minus y minus b square is equal to x plus c square. So what is the solution of this problem? The solution will be x plus c square plus y minus b square, x plus c y minus b square is equal to 1. This is the solution. It represents a sort of circle, isn't this? This is the solution of this differential equation. This is the direct solution because it does not involve p. We have no need to eliminate p. P gets eliminated when we replace p by dy by dx. This we discussed with you some mixed problems on this 4 cases. Now we have, I will discuss with you the next lecture, that will be Clairaut's form. Clairaut's form is nothing. Clairaut's equation, you did it. You have just the case when y is a function of x and p. Y is a function of x and p, the first case that we did. You understand that is the Clairaut's form. I will give you the what is the beauty of Clairaut's form. If y is a function of x and p, we have already done those questions. So why the name Clairaut's form? What was the utility of this Clairaut's form? You will see it in next lecture, and till that you wait and revise the today's lecture. Thank you very much. See you next. Okay.